Hey, grade eights. Okay, we're finishing up the last section of chapter 9, which has gone quick. Again, this is just sort of it's an important chapter looking at relationships and graphs and the relationship between equations and graphs. And it's a lot of what you'll be doing in math in the years to come, but you'll be doing a lot of it more again later. So don't stress too much about this chapter. There will be a little quiz, final chapter quiz, testing like last time. But really it's just, we're looking at graphs and equations like this here. And can you turn an equation and can you graph it? Can you turn it into a table of values? Can you have a table of values and find what the equation is or the relationship? And that's about it. Okay, so I'm just going to go through some example questions to sort of go over these concepts. I'm writing, I want a thin line, and I make it red actually. There we go. Okay, so if we have this relationship, y is equal to 2x plus 3, let's use it to answer the following. So first, make a table of values. Use integers only. So what we're saying is, okay, if you have your x value and you have your y value, what is the y value equal to when x is equal to certain things? So we can find this out. We can say, okay, well, if x is equal to 1, or let's actually even say x is equal to 0, what is y equal to? Well, we can substitute this 0 in for x. So if we put 0 in for x, we can find out what y would be equal to. If x is 0, it's 2 times 0, which is 0, plus 3, which is 3. So y would be equal to 3. Okay, if x is equal to 1, well, what is y equal to? So again, substitute in for x, 1. Now you have 2 times 1 instead of 2 times x. 2 times 1 is 2, plus 3 is 5. So 5. Okay, if x is equal to 2, substitute in for x. 2 times 2 is 4, plus 3 is 7. 3, we can see a pattern now. Y is going up by 2 each time. We can also double check with x. 2 times 3 is 6, plus 3 is 9. Makes sense. 4. 2 times 4 is 8, plus 3 is 11. And, well, we could do another one. 5, that would be 13, because we see this pattern now. 6 would be 15. And let's double check. 2 times 6 is 12, plus 3 is 15. So, yes, that makes sense. Okay? So that would be our table of values that we can make from this equation. So you can have a table of values, and you can use it to find the equation. You can also have an equation and use it to make a table of values. So you can go either way. And we notice that y is going up by 2 each time. And when y is equal, or when x is equal to 0, y is equal to 3, which gives us our constant, the fact that we're adding 3. Okay, so how much it goes up by each time? That it's going up by 2 each time means that you're going to be multiplying by 2. And that when x is equal to 0, y is equal to 3 gives you your constant. So that's how we could have found that equation if we didn't have it and only had the table of values. Okay, so that was A, we made the table of values. B, we have to graph the order pairs. So if we have our graph, 1, 2, going up on the y, 5, 6, 7, and then on the x, 1, 2, 3, 4, 5, 6, 7. I guess this will actually need to go up 8, 9, 10, 11. Okay, so when each of these make a coordinate pair, so when x is equal to 0, y is equal to 3, so we have a point right here. When x is equal to 1, we go to x is equal to 1, y is equal to 5, so we go up to 5. When x is equal to 2, y is equal to 7. When x is equal to 3, 9, x is equal to 4, y is equal to, it would be up here, 11. Okay, there's our graph now. And depending on what the situation is, now it doesn't tell us what y and x are representing here. You maybe would connect them with a line if it makes sense for there to be points between those dots, but maybe not. So what are the coordinates for the point that would lie on the y-axis. What is the point that lies on the y-axis? The y-axis is the vertical one. Well, that coordinate is 0, 3. So when x is equal to 0, that's what it shows, y is equal to 3. That's called the y-intercept, where the line intersects the y-axis. And this constant is always the y-intercept, because that's what it's equal to when x is equal to 0. Okay? So all we were really mainly doing here was taking our equation, turning it into a table of values, and then taking that table of values, turning it into a graph. That's the main thing. Okay, so here we have a situation. Paula rents a lawnmower for $8 an hour. A formula representing this relationship is C, the cost, is equal to 8T. So where C is the rental cost in dollars, and T is the time in hours. Okay, so that makes sense. If it's $8 for every hour, you have to times that $8 by how many hours you've rented it, and that would give you C, the total cost for renting it. So let's make a table of values for A. So we have our time, and we have the cost that you'd have to pay for each time. So time is the independent value here. So how much time you use it for changes the cost. So cost is the dependent value. It changes based on time. So since time is independent, it doesn't change based on cost, but cost changes based on time. Time is the x value, so we put it first. Time is almost always the x value. So when time is equal to 0, if you have it for 0 hours, what would the cost be? Well, it makes sense that it would be $0. If you borrow it for, or if you rent it for 1 hour, you substitute that in for t. 8 times 1 is 8. You pay $8. If you rent it for 2 hours, 2 times 8 is 16. 3 hours, 3 times 8 is 24. Okay, so we're just going up by 8 each time. 4 times 8 is 32. 5 times 8 is 40. Okay. Okay, so there's our table of values. So graph the ordered pairs in your table of values. So let's put time on the bottom here, and then cost going up our y-axis. So time, 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours, 7 hours, 8 hours, and continues. Now for the cost, you don't necessarily have to go up by ones, because our first point when t is equal to 1, when 1 hour is going to be at 8. So you could actually just go up by 8s. So 8, 16, 24, 32, 40, 48, and so on. Okay, so now that we actually have to put these points down, when t is equal to 0, y is equal to 0, so that point is there. So the y-intercept is at y equals 0. That's because there is no constant. You're not adding or subtracting anything afterwards. So at t equals 1, when it's 1 hour, the cost is 8. 2 hours, the cost is 16. 3 hours, the cost is 24. And it goes up in this straight line. Okay. There's our graph. So is it reasonable to have points between those on the graph? Explain. Well, it sort of depends on the rental company, but would it make sense that you could pay, well, between 8 and 16 would be $12 for an hour and a half time? Maybe that would be allowed, but usually if they give you a rate of $8 per hour, they just round up to whatever hours after. So if you use it for an hour and 10 minutes, they're actually just going to charge you 2 hours. They don't usually charge you by the fraction of an hour. So for most cases, you'd probably say no, you wouldn't get charged any amounts in between. They would just always round up to the nearest whole hour. Because if you just, used it for 1 hour and 7 minutes, they're not going to figure out what fraction of an hour, 7 minutes is, and only charge you that. They'll just say, well, you went over an hour, that's 2 hours worth. So no, it doesn't make sense. There'd be points in between. So D, calculate the cost to rent for 12 hours. Well, if the hours would be the time, so that'd be what T is equal to. So we can actually just put this into our equation. So if we're solving D, C is equal to 8T. Well, if T is equal to 12, the cost would be equal to 8 times by 12. Well, 8 times by 12, well, 8 times by 10 is 80. 8 times by 2 is 16, so that would be 80 plus 16 is 96. So it'd be $96 to rent it for 12 hours. Okay, so we can just substitute in. Okay, I hope pretty straightforward. You're just taking the equation, making the table of values, making the graph from there. That's about it. So just quickly evaluating an equation. So doing this substitution in. So if x is equal to 6, let's evaluate y is equal to 2x minus 5. Well, if x is equal to 6, then this would be y is equal to 2 times by 6 minus 5. Well, y would be equal to 2 times 6 is 12 minus 5, so y is equal to 7. Okay, so whatever x is equal to, if they tell us that, we can just substitute that in for x. What if x is equal to negative 2 and b here? Well, then y would be equal to 2 times by negative 2 minus 5, which would be equal to 2 times by negative 2. Positive and negative together is a negative. 2 times 2 is 4, so negative 4 minus 5. So negative 4 minus 5 positives would be going down to negative 9. So y would be equal to negative 9. What about when x is equal to 0? Well, y would be equal to 2 times 0 minus 5, which is equal to 0 minus 5, which is equal to negative 5. Hey, when x is equal to 0, y is equal to negative 5. Negative 5 is here too. So when the x value is equal to 0, that is going to only just be leaving the constant because x times 2, or whatever, times 0 is always 0. Okay, and D, a little bit of a tricky one because it's saying y is equal to 23. Well, if y is equal to 23, then we substitute that in for y, so we'd have 23 is equal to 2x minus 5. Now we have to find what x is equal to. This will be more what we're doing next unit, but we did do this in grade 7. If we just have to find x by itself, we need to get rid of, just going to quickly change colors, we need to get rid of this negative 5. So we add 5 here, we add 5 here. Now I am left with 28 is equal to 2x. X is being multiplied by 2, so I'm going to have to do the opposite. Divide by 2 and divide by 2. They cancel out. 28 divided by 2 is equal to x, so x is equal to 14. Okay, if this one, solving for x when you just have y, is a little bit confusing, don't worry. That's what this next chapter after this is actually all about. We'll be doing that type of thing when you just are trying to find x. So don't stress about it. We did do it last year, so some of you may remember. If you don't worry too much. Okay, and that's it for this week. There'll just be textbook assignment, no quiz or anything, but just make sure, do the questions, actually graph it if it says to graph it. Let me know if you have any questions. See you later, grade 8s.